Hi everybody, I'm Greg Fishel and welcome to bonus weather video number 1 for this week, and it has to do with satellites. And this was actually an idea that I got from one of our subscribers today, and that person wanted to know more about satellites, so I figured why not? We haven't really talked about that in a whole lot of detail, so let's go on ahead and do it. So we'll talk maybe even more than you really wanted to know about satellites, but the acronym GOES stands for Geostationary Operational Environmental Satellites. And I think I've told this story before, but many, many years ago, early on in my career, I was at a American Meteorological Society conference, and the speaker for the luncheon that day was Fred Sanders, who is a world-renowned meteorologist. Unfortunately, passed away several years ago, but just a brilliant, brilliant man. And so he was kidding around, and he said, you know, there are too many acronyms in the world, and I'm going to start a no-acronym project, or NAP. And so that gave you an idea as to what kind of a sense of humor he had, and he made so many contributions to the field of meteorology, and he has been sorely missed ever since he left this planet. All right, so let's take a look at some interesting facts about the satellites. Geostationary means that the satellite is moving at the same speed as the Earth, and so it remains stationary over a given area. Now, the polar orbiting satellites don't remain stationary. They're much lower down, closer to the Earth, and so they sort of take a swipe every couple of hours at the same general region, but they don't remain stationary over the same area. So with this type of satellite and in this positioning, then if we take pictures like every minute, we can get amazing imagery of severe weather outbreaks and this type of thing. And again, we can keep that picture centered on exactly that same spot continuously. And so it really helps us out in analyzing what's going on. Now, the GOES East satellite, there are two, GOES East and GOES West. GOES East is a 75.2 west longitude, and it's over the equator. Okay, so just for reference, Raleigh-Durham is about 78.8, so it's not that far away from our longitude line. And then GOES West is at 137.2 west longitude, which is off the west coast, and that, again, is over the equator. Both satellites are at an altitude of 22,236 miles, which is the exact altitude they need to be at in order to be moving at the same speed that the Earth does. If it's lower than that or higher than that, it's not going to work. So it's got to be at 22,236 miles. Now, we take a look at various products from the satellites, and the shorter wavelengths, which would be along the lines of the visible satellite imagery that I show you, has a resolution of as high as half a kilometer. Okay, so very high resolution imagery. And then the longer wavelengths, which would be like the infrared pictures that I show you, which are the only pictures I can show you at night because when it gets dark, you can't look at the visible part of the spectrum anymore. So the resolution on that isn't quite as good, but it's still pretty darn good at 2 kilometers. Okay, some more interesting facts here. Each satellite has 6 different instruments on board. Now, the primary instrument that everybody is familiar with is called the ABI. Here we are, another acronym, the Advanced Baseline Imager. And this is the one that produces all of the satellite imagery that I show you and that you'll see on TV stations and cable news channels and all that kind of stuff. That's where all that's coming from. Now, within that, there are 16 different bands or wavelengths that we look at, and we'll talk more about how important that is in just a little bit. Now, here are some of the things that I learned today. I was not fully aware of all of this. The GLM is another instrument. It's called the Geostationary Lightning Mapper, and it can actually detect both in-cloud and cloud-to-ground lightning strikes from space. Okay, so that serves that purpose. Then the EXIS, which is the ultraviolet and X-ray irradiance sensors, take a look at the upper atmosphere and they detect solar flares, whether or not solar flares are going on in that part of the atmosphere. The SUVI is the Solar Ultraviolet Imager, which is basically a telescope that monitors the sun and looks out for not only solar flares, but what are called I believe it's mass coronal ejections and that type of thing. So it basically is looking at the sun all the time. The MAG, or the magnetometer, measures the magnetic field in either the outer regions of the atmosphere or just barely into space. And there can be some important information derived from this in terms of charged particles, which can actually be a problem for spacecraft or other satellites, that type of thing. So that takes care of that. And then finally, I'll get out of the road here, the SEISS, the Space Environment In Situ Suite, which monitors proton, electron, and heavy ion fluxes. And I know nothing about any of that, okay? So if you do, then let me know. But that's one of the 6 instruments, and that is the purpose that it serves. All right, so this is the electromagnetic spectrum. This is basically all the wavelengths of all the radiation that is traveling through space and through our air all the time. And you can see that the longer wavelengths are up in here. Okay, and a wavelength is defined as the distance between like one crest to another crest or one trough to another trough, okay? So these are the longer wavelengths, and then they get progressively shorter as you go into this part of the spectrum. The long wavelengths, for instance, this would be AM radio down in here. This is FM radio, cell phones and Wi-Fi, microwave ovens in this general region here. And then the wavelength, oops, let me go back here. This particular wavelength is the wavelength at which humans radiate heat. But we don't see that because the human eyeball is only sensitive to wavelengths of anywhere from 0.4 to 0.7 microns. And a micron is a millionth of a meter, okay? So this is the visible spectrum over in here. Remotes that you use to control your TV and other things are just a little bit longer than that, than the visible spectrum. Visible light in here. And then sunburn is on the upper end of the visible spectrum. And then you go over here to medical x-rays and nuclear power, okay, over in this area. So this is the whole gamut here of all the different wavelengths. And again, when we show you an infrared picture, that's the only way we can show you a cloud imagery or any cloud imagery at night, because when it gets dark, then the human eyeball can't sense infrared imagery, and so we've got to look at it at the clouds in a different way, and we're able to do that by taking a look at longer wavelengths, okay? Now here's the area covered by the GOES West satellite, and it does extend into the eastern part of the United States, but its main job is to look directly down on the western part of the United States and the Pacific, and then the eastern satellite covers the Atlantic, which is great for tropical activity, and also zeroes in on the eastern part of the United States. Last but not least, I'm just going to show you 3 examples of the types of imagery that I show you every day, or most every day. And remember, there are 16 different bands, and I'm only showing you 3 of them, okay? This is the visible band, which is number 2, and this is at a wavelength of 0.64 microns, so this is in the visible range of the spectrum that the human eyeball can see, and it's called the visible red band. There's actually also a visible blue band. Blue has a shorter wavelength than red, and so the red is at about 0.64, and I think the blue is at about 0.47 or something like that. But anyways, this is like if you were up in the spacecraft with a camera taking a picture, this is exactly what you would see. This image was taken a little bit after noon today. Now, ABI band number 9 is the wavelength that we look at for the water vapor imagery in the middle levels of the atmosphere. And the wavelength for that is at about 6.9 microns. And so here, even if there are no clouds present, the satellite can detect different levels of water vapor, different amounts of water vapor. So the yellow colors here indicate dry air in the middle levels of the atmosphere, and then where you get progressively darker, then there's more water vapor present, and then it also does show actual clouds, and you can see those down in here. Now, if we go to the last example here, this is ABI band number 14. This is the infrared, the traditional infrared band, and it has a wavelength of 11.2 microns. And here you can see that it shows this boundary between the low clouds up in here and the sunny air or clear air down in here, and then the different colors represent the temperatures of the clouds. And so once you get up into here and here, these are clouds that have very cold temperatures, and the only way they can be that cold is that they're really, really high up. And so if I go back to the visible here, you can see that same boundary between the clouds and the clear skies, But if it was nighttime, you wouldn't be able to see it because it would be dark. And so the only way you could see it is by using something like this, the infrared imagery, which is going to show you the temperature difference between the land and the clouds, okay? And since the clouds are a little higher up than the land, then they show up as being a little bit colder, and so you can see that boundary there very, very effectively, even though it is at nighttime. Okay, that's a lot of information. I confess that, no question about it. But I thought as long as I was delving into this, I might as well delve into it whole hog. And so hopefully you found that interesting. And maybe we'll do, I know we did something about radar late last year, but maybe we'll do another in-depth one about radar and how the National Weather Service radars operate and why they do what they do and what they can detect. So that's it for now. Hope you have a wonderful Tuesday evening. We'll have another bonus weather video coming up for you on Friday, and another daily weather update, of course, coming up tomorrow afternoon. We'll hope you'll join us for both of those. So you all have a great Tuesday evening, and we'll talk to you soon. Take care.